Welcome back, dear learners, to the course of Animal Waste Management. And this is the fourth week, the fifth lecture of the module Animal Waste and Environment, the effect on the environment. Myself, Dr. Vipin Maurya, Assistant Professor, Department of Livestock Production Management, Faculty of Veterinary and Animal Science, Institute of Agricultural Science, Banaras Hindu University, and we will be discussing today in the fourth week, the fifth lecture, the waste utilization and carbon sequestration. So, this is a word carbon sequestration, many of you have never heard it. So, carbon sequestration simply means converting the atmospheric carbon dioxide into various methods of soil packing or the soil, this carbon sink, that is agroforestry, the forestry, the silvipasture. So, animal waste management has emerged as a critical area of concern in the agriculture, not only due to its impact in direct implications of the environmental sustainability, but also its potential role in mitigating the climate change. Among the many environmental benefits associated with the effective animal waste management, carbon sequestration stands out to be as the significant and most promising strategy. So, as we have discussed, carbon sequestration involves capturing and storing the atmospheric carbon dioxide in various carbon sinks like the soil, the forest, the wetlands, and it is a process of capturing and storing the atmospheric carbon dioxide to reduce the effect on the climate change. The primary method of the carbon sequestering include the biological sequestration like the plants and the soils, the geological sequestration like the underground storage, and the mechanism of the carbon sequestration in the soil, it is the soil organic carbon, where the organic matter in the soil including the plants, residues and decomposed animal waste contributes to the soil organic carbon. The formation and the stabilization of the soil organic carbon depends upon the factors such as the soil type, the land management practices and the climate. Microbial activity. The soil microorganisms decompose the organic matter, leading to the formation of the stable organic compounds that enhance the carbon storage. The soil aggregation. The organic matter binds the soil particles together, creating stable aggregate that protects the carbon from the decomposition. Now, coming to the role of the animal waste in carbon sequestration. So, animal waste, it can significantly impact soil carbon sequestration through its effect, soil organic matter and microbial activity. So, the proper management of the animal waste can enhance its role in the carbon sequestration. So, what are the impacts of the animal waste on the soil properties? Organic matter addition, then the nutrient supply and the soil structure improvement. So, as we have already discussed, the animal waste adds on the organic matter to the soil, which increases the soil organic carbon content, which particularly benefits the soil with the low organic matter level. And it supplies the essential nutrients to the soil, which enhances the plant growth, leading to increased root biomass and organic matter input into the soil. So, there is an overall improvement in the soil structure with the application of the waste or the animal waste into the soil. Now, management practices to enhance the carbon sequestration can be done by the composting. So, composting of the animal waste converts it into the stable form of the organic matter, which can improve the soil carbon storage and reduce the greenhouse gas emissions. Incorporation into the soil. So, incorporating the animal waste into the soil rather than applying it on the surface can enhance the decomposition and increase the carbon sequestration. In India, it is a process of applying the carbon waste or the animal waste onto the surface of the land. Just people try to throw out the waste, the dung or the this animal feces directly onto the surface of the soil thinking that it will be converted into the manure. But if it is applied or incorporated into the soil, then it will be more beneficial to the soil, as well as the carbon sequestration will be done more efficiently. And another way is the crop. So, covering the crops in conjugation with the animal waste application can further enhance the carbon soil storage by increasing the organic matter input into and reducing the soil erosion. Then manure management system. Implementing efficient manure management system such as anaerobic digesters can reduce the methane emission and produce compost that contributes to the soil sequestration, or we can say the carbon sequestration into the soil. So, soil carbon sequestration via the manure application, when the animal waste is applied to the agricultural land as fertilizer, it not only enhances the soil with the nutrients but also contributes to the carbon sequestration. Organic matter in the manure increases the soil carbon content, improving the soil health and structure. Manure application enhances the microbial activity in the soil, facilitating the conversion of the organic carbon into the stable carbon, soil carbon, and this reduces the atmospheric carbon dioxide level while simultaneously improving the soil fertility and crop productivity. However, the proper management of the management practices are crucial to prevent the nutrient runoff and over application, which can lead to nitrogen leaching and other environmental issues. Then coming to the biochar and pyrolysis for the carbon sequestration. So, biochar we have already discussed, this is a carbon rich material produced through the pyrolysis, the thermal decomposition of the organic matter in the absence of the oxygen. So, this pyrolysis or the biochar production, it is gaining attention for its carbon sequestration potential when applied to the soil. The biochar acts as a stable form of the carbon resistant to the decomposition for the centuries. The biochar improves the water retention, nutrient availability and microbial activity, enhancing the soil health while sequestering the carbon. In the animal waste management, biochar can be produced from the manure and other organic waste, turning a problematic waste product into a valuable soil amendment. Now, the soil carbon sequestration and land management. So, soil carbon sequestration, which is a process through which the atmospheric carbon dioxide is captured and into the soil and forming a part of the natural global carbon cycle. So, carbon may be stored in the soil for thousands of years in an undisturbed natural ecosystem. However, the conversion of the natural land and farmlands has depleted soil organic carbon stock and released the stored carbon into the atmosphere. Livestock grazing systems have been particularly responsible for the loss of the significant amount of the soil carbon over the past 6 decades. Composting for the carbon retention. So, we have already studied in the previous lectures that how composting is a very efficient way of manure disposal, manure reuse, manure treatment and fertilizer generation. But here the composting is another effective way to manage the animal waste while promoting the carbon sequestration. So, during composting, the organic carbon in the manure is stabilized into the humus and a form of the carbon that remains the soil for extended periods. So, composting also reduces the methane emissions from the manure, and by converting the manure into the stable organic matter, composting not only mitigates the greenhouse gas emission but also improves the soil carbon storage. Then coming to the regenerative grazing, which is again an important aspect of this carbon sequestration. So regenerative grazing, it is an approach involving the rotational grazing on a land for short durations and has been proposed as a solution for improving the soil carbon stock and offsetting the emissions from the livestock farming. This practice aims to mimic the natural grazing patterns and improve the soil health by allowing for periods of the rest and recovery. So, improved grazing management can potentially take up to 63 billion metric tons of the carbon in the vegetation. So, livestock management systems which are currently utilized, they are the pasture or the range system, where the livestock grazing is done on the pasture with no formal waste handling. Manure is spread throughout the pasture range or throughout the system. Daily spread, so manure collected and spread to the fields on the regular basis. Solid storage, so manure is collected and stored in the bulk for extended periods before the disposal. Dry lot, livestock is kept in the paved feedlots. Manure is dried and periodically removed. Deep pit system, where the manure accumulates in the deep pits below the cages and which is typically dry in condition. Then litter waste management system. So manure and the beddings, the shavings, the dust, the sawdust, the sand, they can be collected and removed periodically. Then the paddock. So horses confined to a limited area, manure spread naturally. Liquid slurry, so manure which is mixed with the water and stored in the concrete tanks. Anaerobic lagoons, so manures which are transported to the lagoons for the treatment for producing the biogas and treated the water for the fertilizer. Then pit storage, liquid swine manure stored in the pits before the disposal, and anaerobic digester to produce the biogas and the digestate. Apart from this, we can follow the integrated farm management system. So integrated livestock production with crop production can enhance the carbon sequestration by optimizing the land use and nutrient cycling. Silvopastoral or the silvipastoral system, where the combining of the tree planting with the livestock grazing can increase the carbon sequestration and provide additional benefits such as shade and fodder. Then precision feeding. So using the data-driven approach to optimize livestock feed rations can reduce the waste and improve the feed efficiency, thereby reducing the greenhouse gas emissions. Now, what are the challenges and considerations in carbon sequestration? So, however, relying on the soil carbon sequestration to offset the emissions from the grazing system, it is risky, as the carbon storage in the soil is finite and reversible, meaning that increased emission of the methane and nitrous oxide could offset any gains from the sequestered carbon in the soil. An estimated of 135 gigatons of the carbon take-up would be needed to fully offset these emissions. The impact of regenerative grazing are also highly context dependent and varying based on the soil types, climate and grazing management practices. Despite these uncertainties, the sequestering carbon in soil could contribute to the climate change mitigation in the medium term, particularly in the regions where the conditions have favored the increased carbon storage. So management practices aimed at maintaining or improving the soil carbon offer additional benefits such as improved soil health, erosion control, and reduced emission intensity, which can positively impact the yields and the farmer's income. Now, coming to another very interesting thing, that is the carbon footprint. The concept of the carbon footprint refers to the total amount of the greenhouse gases emitted into the atmosphere as a result of the human activities, which is expressed in the carbon dioxide equivalents. So, understanding the carbon footprint of the animal waste management is crucial for assessing the overall impact of the climate change and developing the strategies to mitigate the effect of the climate change. Greenhouse gas emissions from the animal production. We have already discussed in the whole lecture series regarding the methane gas production, the nitrous oxide gas production, the carbon dioxide, and how it is leading to the this global warming, how they are not how we can minimize the methane production from the animals. So enteric fermentation in the ruminants like the cattle and the sheep, they are the major source of the methane, which are a potent greenhouse gas. So which can be easily handled and converted into various anaerobic conditions. Now, the nitrous oxide, which is primarily produced through the decomposition of the manure and the chemical application of the fertilizers, it is having a potential of 298 times than that of the carbon dioxide. Similarly, the carbon dioxide, we all know, it is produced from everywhere, and additionally the deforestation for the pasture expansion exacerbates the carbon dioxide emission by the reducing the carbon sinks. So the carbon footprint of the livestock varies depending upon the production system, the animal species, and the regional practices. Like the ruminants, which include the sheep, goat, cattle, buffalo, yak, mutton, they have a higher carbon footprint due to the methane production during the enteric fermentation. Like the beef production approximately results 300 kgs of the carbon dioxide equivalent emissions per kg of the beef produced from the buffalo. Similarly, the monogastric animals like the pigs and the poultry, they have a lower carbon footprint due to the monogastric in nature, and pork production has estimated to be 55 kgs of carbon equivalents per kg, whereas broiler chicken produce around 5 kgs of the carbon dioxide equivalent per kg of the meat produced. Now, components of the carbon footprint in animal waste management. So, direct emissions, these include methane and nitrous oxide. Emissions from the animal waste. Methane is produced during the anaerobic decomposition of the organic matter in manure, while the nitrous oxide is released from the application of the manure as a fertilizer. Indirect emissions. These involve the emissions associated with the production and transport of feed, as well as the energy used in the manure management processes such as composting or anaerobic digestion. Then carbon storage benefits. So proper management of the animal waste can contribute to the carbon sequestration in the soil, which helps offset some of the emissions produced. However, the extent of this benefit depends on the effectiveness of the management practices implemented. Now, how we will be measuring the carbon footprint and how we can reduce the carbon footprint. So, measuring, that means quantification of the carbon footprint. So, quantification, means that the accurate measurement of the carbon footprint, which involves the calculating direct and indirect emissions using the established protocols and the tools. So, this includes the monitoring of the methane, nitrous oxide, energy use, and other relevant factors. Now, coming to the mitigation strategies or reducing the carbon footprint of the animal waste, which can be done through several strategies. So, first one is the improved manure management. The second one is the efficient use of the feed and the energy efficiency. So, What does improved manure management means? That utilizing all the practices such as composting, anaerobic digestion to reduce the methane emission and to enhance the carbon storage or the carbon sequestration. Similarly, optimization of the feed formulation to reduce the nitrogen excretion and subsequent nitrous oxide emissions. In last few lectures, we have already understood how we can reduce the methane emission by the use of simple compounds or the simple feed supplements. And finally, the energy efficiency. So, implementing the energy saving measures in the manure management operation for lowering the emission and increasing the carbon sequestration. So, these mitigation strategies for reducing the carbon footprint in the livestock production. So, addressing the carbon footprint of the livestock production requires a combination of the technological innovations, management practices and policy interventions. Methane reduction strategies. Methane reduction is a key target for lowering the carbon footprint of the ruminant livestock. Various strategies have been developed to reduce the enteric methane emission and methane release from the manure. So, as we have discussed that certain feed additives, they have shown promising results in reducing the methane emissions by 30 to 80% into the cattle feed, like 3-nitrooxypropanol, which is also known as 3-NOP. Similarly, we can go for manure management. Anaerobic digestion systems are highly effective at reducing the methane emissions from the manure by capturing the biogas for energy production. So, properly managed anaerobic digesters can reduce the methane emission by 70 to 90% compared to traditional manure storage methods. Another important thing, is waste management. It is the nitrous oxide mitigation. We have already understood about how the methane can be reduced by the use of the feed additives, but this reducing the nitrous oxide or mitigation of the nitrous oxide from emissions from the manure and the organic fertilizers can be achieved through the efficient nutrient management practices itself. So, first one is the precision agriculture technologies such as the GPS guided manure spreaders, nutrient sensors, which enables the farmers to apply the manure and fertilizers more accurately to reduce the nitrous oxide emissions from the over application. And then nitrification inhibitors such as dicyanodiamine, which is also known as DCD, which can reduce the nitrous oxide emissions up to 60% from the manures. Carbon footprint reduction through the improved manure management, which we have already discussed, that the anaerobic digestion and the composting combined with the precision nutrient management can reduces the greenhouse emission from the manure by an average of 50%. Effective manure management includes the strategies such as frequent manure removal, covered storage and the use of the anaerobic digesters to capture the methane emission. Additionally, recycling the manure as the fertilizer helps to reduce the need for the scientific fertilizers which are energy intensive to produce. Anaerobic digestion for manure management is a technology. So, anaerobic digestion that captures the methane from the manure and converts it into the biogas, which can be used as a renewable source of the energy. And this process significantly reduces the methane emission by preventing the anaerobic conditions into the manure management system. And it has given the benefits up to 90%. Now, carbon market and methane offsets. So, carbon markets provide financial incentives for the methane reduction by allowing the farmers to sell their carbon credits for capturing and reducing the methane emission. This approach helps the farmers offset the cost of the methane reduction technologies while contributing to broader climate goals. Carbon offset program that targets the methane emission from the livestock and the manure management could provide the farmer with an additional revenue system. Carbon markets and methane credits. So, India is participating in the global carbon markets where the methane emission from the livestock can be offset through the carbon credits. What are methane credits? Indian farmers can sell their carbon credits in the international market by adopting the technologies that reduce the methane emission. These carbon credits incentivize the adoption of the methane reduction technologies. In 2021, India sold over 1 million tons of the carbon equivalent in the carbon credits generated through the biogas and manure management projects. These credits are expected to grow as more methane capture technologies are implemented. Now, what are the challenges and limitations? So, while the potential benefit of the animal waste for carbon sequestration and reduced carbon footprints are significant, several challenges and limitations must be addressed, like the greenhouse gas emission, variability in the soil response, and the economic and the practical considerations. So, greenhouse gas like the methane and the nitrous oxide, which offsets the benefits of the carbon sequestration. The variability in the soil response, the effectiveness of the animal waste in enhancing the soil carbon sequestration can vary depending on the soil type, climate, and land management practices. Understanding these variations is crucial for optimizing the carbon sequestration strategies. Then, economic and practical considerations. The implementation of the carbon sequestration practices involving the animal waste can incur the additional cost and requires the change in the management practices, economic incentives, and support to the farmers, which are essential for encouraging the adoption of these practices. Precision waste management, which is an innovative approach that leverages the advanced technologies and data-driven strategies to optimize the handling, processing, and utilization of the waste, including the animal waste, to achieve the environmental and economic goals. Carbon sequestration and precision waste technologies focuses on maximizing the potential waste material to capture and store the atmospheric carbon dioxide into the soil. So, precision waste management in the animal waste, a critical component of the waste management with significant implication of the carbon sequestration. Effective management practices can enhance the soil carbon storage and reduce the greenhouse gas emissions. Waste characterization. So, characterizing this animal waste involves the determining its composition, including the nutrient content, moisture level, and organic matter. So, this is very important for tailoring the management practices and reducing the environmental impact. Then the monitoring system. Advanced monitoring system includes the sensors, the data loggers, enable the real-time tracking of the waste characterization and the environmental conditions to support the precision application and the effective management by adjusting the management practices based on the current data to improve the efficiency and the effectability. Then, application technologies like VRT, variable rate technology, which allows the precision application of the animal waste based on the specific field requirements, like the optimized nutrient distribution and improved carbon sequestration, and GPS guided equipments for ensuring that accurate placement of the waste material, reducing the overlap and minimizing the environmental impacts. So, waste losses are reduced and efficiency is enhanced. So, reducing the greenhouse gas emission, supporting the sustainable agriculture by improving the soil health, boosting the crop yield, minimizing the methane emission, controlling the nitrous oxide emission. So, these are the methods by which we can efficiently manage the various greenhouse gases, we can save our environment, and we can go for making various fuels, biofuels, biogas, and renewable sources of energy. So, finally, to conclude, animal waste management has a substantial role in carbon footprint due to the emissions of the nitrous oxide, carbon dioxide, and methane. Properly managed systems such as composting, anaerobic digestion, and precision feeding can help in reducing the greenhouse gas emissions and improving the carbon sequestration in the soil. Regenerative grazing and agroforestry can increase the carbon stock in the soil, while biogas generation from manure can reduce the methane emissions. So, livestock systems must balance the nutrient cycling and efficient manure management to ensure lower emission, improve soil health, and boost the productivity while sequestering the carbon. Carbon footprint reduction from the livestock system not only mitigates the climate change but also more sustainable and eco-friendly practices. So, with this, we come to end to the lecture of carbon sequestration and the waste utilization. We have finally learned the sequestration of the carbon into the soil, the carbon sinks into various land, environment, forest, and various areas. So, dear learners, keep learning. If you have any doubt, you can directly contact us. Feel free to ask any of your queries. Keep learning, keep enjoying. Thank you. Thank you, friends.